Hello friends, myself Dr. Nandakumar Raubawale from College of Engineering Ambazogai is going to deal with Applied Thermodynamics 1. This is our 9th lecture. In previous lecture, we discussed about draught, classification of draught, natural draught, chimney draught, condition for maximum discharge through chimney and maximum discharge. Now we are left with chimney efficiency, draught losses, artificial draught, classification of artificial draught, comparison of forced and induced draught, advantages of mechanical draught over natural draught, steam jet draught, and numerical on draught. So now coming to the chimney efficiency, which was left in previous class. Actually we were supposed to cover in previous class. Now today we will discuss about chimney efficiency. What this chimney efficiency is: a certain minimum flue gas temperature is required to produce a required draught with a given height of chimney, that is natural draught. Therefore, temperature of gases leaving the chimney in case of natural draught has to be higher than the flue gas temperature in case of artificial draught. In case of artificial draught, the temperature of gases does not play any role in production of draught, that is the pressure difference. But in case of a natural draught, the temperature of gases plays very important role. Say Tg is the temperature of gas. If Tg is higher, then density of hot gases rho g is lower. Lower is the density of gases. Lower is the density of gases. The pressure difference delta P created will be higher, and higher is the pressure difference, then that is nothing but larger is the draught. So draught depends on the delta P pressure, and pressure depends on density, and this density of gases depends on temperature. Higher is the temperature of gases, lower will be the density, lower is the density, higher will be the pressure difference, and that causes the gases to move rapidly through the combustion chamber, and fresh air enters into the combustion chamber. Therefore, in case of artificial draught, this temperature of hot gases does not play any role, because in case of artificial draught, the gases are blown out or removed with the help of a fan or blower, and there is a mechanical means which will create the flow of hot gases or air into the combustion chamber. But in case of natural draught, only this density of gases play important role to create the pressure difference, and therefore to achieve higher draught, the gases must be at higher temperature, and if we allow these gases to pass into the atmosphere at higher temperature, indirectly we are going to lose heat energy into the atmosphere along with the hot gases. So our aim is to extract maximum heat energy from the flue gases, and if we extract maximum heat energy from flue gases, then temperature gets reduced, and if temperature gets reduced, then if density will be more, and if density is more, then discharge will be less, or delta P will be less. Therefore it affects the draught. So heat carried away by flue gases to produce the required draught could have been used either in an economizer or in air preheater, improving the thermal efficiency of boiler. Let Tg be the T suffix G be the absolute temperature of flue gases. Flue gases leaving the chimney. Leaving the chimney to create draught. So this draught, if we measure in water column, so this draught is in meters of water column. It may be millimeters of water column or centimeters of water column. That depends. Then, say for example, instead of using a natural draught, if we are using artificial draught, then the temperature of gases which are uh, passed into the atmosphere using artificial draught, the absolute temperature of gases, temperature of flue gases leaving chimney, in case of artificial draught. Artificial draught is TM, say. Now CPG, specific heat of gas. CPG is specific heat of gas or mean specific heat of gas. Heat of gas or flue gas in kilojoules per kg Kelvin. The extra heat is carried by the gases as the gases are moving at the higher temperature. In case of mechanical draught or artificial draught, the gas temperature is Tm, and in case of natural draught, gas temperature is Tg. Always Tg is higher compared to Tm because the draught depends on gas temperature, and to achieve higher draught we have to allow gases at higher temperature to pass through the chimney. Therefore the heat energy is lost along with the hot gases. Therefore amount of heat lost per kg of gas, if we want to find out the extra heat carried, the extra heat carried by flue gases in natural draught, is given by, generally heat is carried by mCp delta T. So here m, mass of gases, is assumed to be 1. So this is equal to Cpg. Cp is the specific heat at constant pressure of gas, and Tg minus Tm is, this is the extra heat carried by the hot gases, where Tg is the gas temperature which is always greater than the temperature of gases passed in the artificial draught. So therefore the maximum energy this head would give to 1 kg of air at the cost of extra head. So here the draught pressure produced by natural draught system in meters of hot gases. So we obtained two kinds of equations: the draught produced in terms of water column, draught produced in hot gas column. So the draught produced by natural draught system Natural draught system. Draught system in meters of hot gases column. Hot gases. This is given by, already we have derived this equation, Hg is equal to H bracket Ma divided by Ma plus 1, close this bracket, into Tg divided by Ta minus 1 meters of hot gas column. So this head imparts the energy for the flow of gases through the chimney. Now coming to this maximum energy or head, which 1 kg of air or 1 kg of gases will gain because of loss of heat energy. So if we are going to allow gases at temperature Tg which are higher than Tm into the atmosphere, so we can have here the maximum energy this head would give to 1 kg of 1 kg of air at the cost of extra heat. Extra heat energy is carried by gases because gases are passing at temperature Tg, so which is equal to 1 is the mass into H into Ma divided by Ma plus 1 into Tg divided by Ta minus 1 kilojoules of energy is provided. Now the chimney efficiency has to be defined. It is given by the ratio of maximum energy head that is achieved by the cost of extra heat carried by hot gases to the amount of heat energy, extra amount of heat energy carried by the gases. So chimney efficiency is given by chimney efficiency Ch is equal to H. So this we call as equation number 2, and equation number 1 already which we have written here. So this we call as equation number 1. So this is the ratio of equation number 2 divided by equation number 1, bracket Ma divided by Ma plus 1 into Tg divided by Ta minus 1 whole divided by equation number 1, which is given here, Cpg in bracket Tg minus Tm. So this is the extra heat energy carried by the gases to produce this much amount of draught. So this into 100 gives us the efficiency of chimney. Now coming to the losses, draught losses, that means the pressure difference which is created is lost because of certain reasons. What are the causes which are making to reduce the pressure difference which is achieved by the density difference of gases. So surely the gases are passed through the passages like chimney or ducts. So friction is going to happen or take place along between the flue gases and the walls of passage, and that friction causes the loss of pressure difference. This is one reason. Loss near the bends in the gas flow circuit, if there is a flow path which has got the turns in between. So this turnings in the flow path of hot gases also cause the loss of pressure difference. Then frictional head in different equipments. So when these gases are passed through economizer or air preheater, so certainly number of tubes will come in path of flow of gas, and that is going to cause head loss into the equipments. Then part of total draught used to impart velocity. So some part of draught is used to impart velocity to the gases to pass through the combustion chamber. So some part of draught is used to impart velocity to the gases. So total draught is utilized in various ways. Major part is utilized to create the velocity for the gases or to make gases to flow, and rest of the draught produced is lost in overcoming friction in equipments as well as in the bends as well as in the friction along with the passage. Now, why this artificial draught is preferred? Draught used must be independent of atmospheric condition. So the draught which we are going to produce in natural, Tg is the gas temperature and Ta is the ambient air temperature. So larger is the difference between Tg and Ta, larger will be the draught. So if Tg is increased or Ta is decreased, so anyone, this has to be increased or Ta has to be reduced, and that creates higher draught. If the ambient temperature increases, then the draught is going to get affected and draught gets reduced. So larger is the difference between Tg and Ta, larger will be the draught. And if the ambient temperature changes, that affects on the draught produced. So generally the draught produced should not depend on the atmospheric condition, must have greater flexibility to the fluctuating loads. So many times the load over the plant is going to increase, and when increase or decrease, so fluctuation in the load, depending on the fluctuation in the load, fuel burned into the combustion chamber varies, and depending on the fuel burned, so the flow of air or gases has to take place. So there must be flexibility for the flow of air as well as flue gases depending on the load conditions. When load increases, the flow of gases has to be increased, and when load decreases, automatically flow of gases has to be reduced. But this is not possible in case of natural draught, and it is possible in artificial draught. So this artificial draught imparts the velocity of gases, that is discharge of gases 400 into 10 to the power of 3 meter cube per minute to 800 into 10 to the power of 3 meter cube per minute. This is not velocity, this is the volume of gases discharged per minute. Then draught required in thermal power plant is 300 mm of water. So generally it is very high draught, and which is achieved by artificial draught and is not possible to achieve by natural draught. So if we want to use natural draught, then gases which are allowed to pass into the atmosphere will be at higher temperature. There we are going to reduce the efficiency of a boiler plant. So if you want to maintain efficiency of boiler plant, then artificial draught is preferred. To meet this high draught requires artificial draught. So artificial draught is preferred. Artificial draught is economical above 40 mm of water. Wherever we need the draught above 40 mm of water, then we go for artificial draught. Now the draught is classified. So first classification is forced draught, second one is induced draught, and third one is balanced draught. So in case of artificial draught or mechanical draught, we have three categories: forced draught, induced draught, and balanced draught. So we'll discuss all this in detail. So what is forced draught? In case of forced draught, a blower, this is a blower, then this is a furnace where fuel is burned, this is a boiler, then this is economizer, air preheater and chimney. So this blower is placed before this combustion chamber. Blower is placed before combustion chamber, and this blower helps to blow cold air into the combustion chamber, and this force is created, and this sweeps out the flue gases, and these flue gases are going to pass into the economizer, then air preheater and discharge into the atmosphere. In economizer heat is recovered, in air preheater also heat is recovered, and the gases at reduced temperature are passed into the chimney, where this chimney height does not play much role in creating draught. Only this blower is responsible to create the draught here. Therefore this works on the pressure inside this system is greater than the atmospheric pressure. Say for example, PA is atmospheric pressure, and pressure created into this combustion chamber is PB, say, or P blower, we call this as blower, say. So pressure is greater than the atmospheric pressure, so there is no chance that the atmospheric air will enter into this flow path of hot gases. So if there is a leakage, so these gases may come out, but no gas from outside will enter into the system, as the pressure in this system is above atmospheric pressure. Air is forced through the system, and function of chimney is just to discharge gases into the atmosphere. Chimney is just a means to exhaust gases at a higher altitude in order to protect the people in that area, or occupants in that area, from pollution. So chimney is used to just exhaust gases at higher altitude. So here the pressure is above atmospheric pressure, and this blower is going to handle only cold air. Cold air is passed through the blower, so it handles only less quantity. Only the air, pure air, is taken by this blower and passed into the combustion chamber. So this is the advantage here. The pressure inside this combustion chamber is maintained above the atmospheric pressure. Then in case of induced draught, it is reverse of forced draught. So here blower is placed at the end before chimney, and this blower is having the function to suck the air passing through flue gases passing through economizer, air preheater and combustion chamber. So it creates the suction. Therefore the pressure in the system is below atmospheric pressure. Say atmospheric pressure is PA, then pressure in the system we say PS. PS is less than PA, atmospheric pressure, and this acts similar to the natural draught. In case of natural draught also, vacuum is created or pressure is below atmospheric pressure. So here if there is a leakage, so atmospheric air enters in between and reduces the draught which is created, pressure difference created by the blower. So here this blower needs to handle large quantity of gas. So the mass of air in previous case was MA, so only MA is the quantity of air handled by blower in case of forced draught. But in case of induced draught, so mass of gases is equal to MA plus 1. So large quantity of gases have to be handled by blower in case of induced draught, and this blower in case of induced draught is supposed to sustain high gas temperature, whereas in previous case the blower is working with the temperature at ambient air temperature, whereas here blower works at higher temperature, the gas temperature. Therefore design of this blower has to be made with caution, as well as the flue gases which are passing through blower are going to contain ash content, and that ash has got the effect over the blades of blower, that is maintenance of blower becomes difficult, as well as the erosion of blade takes place earlier. So pressure through system is below atmospheric pressure, and that causes the loss of draught due to the leakage. If there is a leakage, so surrounding air enters instead of sucking the flue gases from combustion chamber, so it starts to suck atmospheric air if there is a leakage in the system. So action of induced draught is very similar to the chimney draught, natural draught. So blower handles hot gases, therefore it has to be designed for higher temperature. The quantity of gases handled by blower is more, so it is Ma plus 1. The draught produced is sum of induced draught and chimney draught. Here draught produced, in this case the height of chimney is larger. So chimney also produces the draught and blower also produces draught, and total draught is the sum of draught produced by chimney and draught produced by blower. Then opening of door quenches the fire. So if any door is opened in between, so the surrounding air enters into the furnace and quenches the fire. So air from air preheater is passed into this in order to maintain temperature, and if by mistake or if anyone is going to open door of this furnace, then cold air from atmosphere enters into the combustion chamber and quenches the fire. Then coming to balanced draught. What this balanced draught is? So this balanced draught is combination of induced draught and forced draught. So this uses a fan as well as a induced fan or blower. So here two blowers are used or two fans are used. One is going to force the air into the combustion chamber and another is going to suck the flue gases. So it overcomes the drawbacks of induced draught as well as forced draught. So it overcomes demerits of forced draught as well as induced draught. It prevents the blowout of flames and leakages of air. So in previous case, in first case, that is in case of forced draught, there was a blowout. If there is a leakage, the hot gases will come out. In case of induced draught, if there is a leakage, the air enters into this system. So both these drawbacks are overcome in this balanced draught. Air pressure is below grate is above atmospheric pressure. So here pressure is above atmospheric pressure, and that creates sufficient flow of air or uniform flow of air into the combustion chamber, and proper combustion of fuel will take place. So this is one advantage, and removes exhaust gases as quickly as possible from combustion zone. So these are the advantages of balanced draught. Now coming to next, comparison between forced and induced draught. So forced draught requires less power because less quantity of air is handled by blower MEA, but in case of induced draught, gases are mg is equal to Ma plus 1. If we burn 1 kg of fuel, then it produces hot gas of mass Ma plus 1. So more power is required in induced draught. Fewer gases are handled by forced draught, whereas more gases are handled by a blower of induced draught. The cold air passes through the blower. In case of forced draught, cold air enters into the blower, but in case of induced draught, hot gases are passed into the blower. So lower maintenance is required for a forced draught because the blower is exposed to low temperature gases, and here it requires higher maintenance because it is exposed to higher temperature, as well as the gases passing through the blower are going to contain ash particles, and that causes damage to the blower. So leakage is not major problem in forced draught, whereas leakage in the induced draught causes loss of draught or insufficient circulation of air may cause. So airflow is uniform in forced draught, whereas in case of induced draught, airflow is not uniform. Door opening does not quench the fire. If in case of forced draught, if we open door of a combustion chamber, so atmospheric air does not enter into the combustion chamber because pressure in the combustion chamber is larger than the atmospheric pressure. But in case of induced draught, the inner side pressure is lower, and if we open the door, the surrounding air enters into the combustion chamber and quenches the fire. That in turn reduces the steam generation rate. Then advantages of mechanical draught over the natural draught. So mechanical draught, the rate of combustion is higher because the air is passed forcibly and proper combustion of fuel takes place. So combustion rate is higher. Better distribution of air in the combustion chamber, better air distribution. So air is passed or properly into the combustion chamber through the holes of a grate. Airflow can be regulated. Airflow can be regulated as we want to increase or decrease airflow rate. That can be done in case of artificial draught, whereas in natural draught the flow rate of air cannot be properly controlled. A mechanical draught is independent of atmospheric condition. Whatsoever may be the ambient air temperature, it does not hamper on the draught produced in case of a mechanical draught. Whereas in natural draught, the atmospheric air temperature also plays important role. If higher is the air temperature, ambient air temperature, then draught gets reduced or it gets affected. Low grade fuel can be used in artificial draught or mechanical draught, whereas in natural draught, high grade fuel is required for combustion. The loss of efficiency to produce draught is zero. So in case of mechanical draught, the temperature of air does not play, sorry, temperature of gases does not play in creation of draught. Therefore the gases can be cooled to any temperature and can be exhausted to the atmosphere. That means maximum heat extraction is possible in case of artificial draught or mechanical draught, but in natural draught it is not possible. The gases which we want to pass into the atmosphere must be at higher temperature, so the height of chimney can be reduced. So in mechanical draught or artificial draught, chimney height does not play much role in creating draught, therefore the height of chimney can be reduced, whereas in natural draught height of chimney must be higher to create higher draught. Then fuel consumption is less by 15%. In artificial draught or mechanical draught, fuel consumption is less because the maximum heat can be recovered in various devices and temperature of gases does not play any role. Therefore maximum amount of heat can be extracted, and if maximum quantity of amount of heat is extracted from flue gases, therefore the amount of fuel to be burned into the combustion chamber is less, and it prevents formation of smoke due to complete and proper combustion. In mechanical draught, proper circulation of air takes place, and due to which complete combustion of fuel is going to happen, and as the complete combustion of fuel take place, so smoke formation or improper combustion may not take place. So smoke formation is less and proper combustion of fuel also takes place. So now coming to the next, steam jet draught. So this is one of the artificial draught which is produced. So here somewhere here there is a combustion chamber where fuel is burned, say. So this is the stack or chimney which is generally used in a locomotive boiler. So here there is a nozzle, steam nozzle. So steam is passed through this nozzle and it is expanded. So when steam is expanded, suddenly pressure drop takes place, and due to pressure drop, so the hot gases are sucked into this smoke chamber or smoke box. So vacuum is created by expansion of steam passing through this nozzle. So steam at high pressure is passed into this nozzle and suddenly steam is expanded. As steam is expanded, pressure drop takes place, and due to pressure drop, so the hot gases from combustion chamber, here combustion chamber is there, so this combustion chamber, the hot gases from combustion chamber pass into these tubes and then enter into the smoke box and then exhausted into the atmosphere. So this is how steam jet draught works. What are the advantages of steam jet? So it is simple and economical. Low grade fuel can be used because it produces draught, effective draught. Exhaust steam can be used to produce draught. So the steam which is to be exhausted at the last is used to produce exhaust. Low maintenance cost is required and less attention. So this draught mechanism requires less space, but it has got a disadvantage. It cannot be started unless high pressure steam is available. Unless steam is produced, this draught system cannot be started. So this is one of the disadvantage of steam jet draught. So now coming to the problem, we have one numerical. Today we will solve one numerical, which is a simple and small problem. So here a boiler is equipped with a chimney of 25-meter height. The height of chimney is given, this is H. The ambient air temperature TA, temperature of air is TA. The temperature of flue gases passing through chimney, hot gases which are passed into the atmosphere, is Tg. If airflow through combustion chamber is 25 kg per kg of fuel, that is mass of air, is 25 kg per kg of fuel burn. Find theoretical draught in centimeters of water. So we have to find out HW in centimeters of water, and then velocity of flue gases passing through chimney. So V, we have to find out velocity of gases, we have to find out. So if 50% of theoretical draught is lost in friction at the grate and passage. So here theoretical draught and actual draught, Hg, say for example Hg is a draught produced in hot gas column. So this hot gas column, draught produced in hot gas column, if we find out using a formula, then we call it as a theoretical. And if we find it considering the losses, then it is actual draught produced. Actual is less than the theoretical. Theoretically we say that there is no loss of head due to friction and all. So but here actually there is a head loss due to friction and all. So there is a loss of head. So now data given we will write. The height of chimney is H is equal to 25 meter. Temperature of air which is given as 23, and absolute temperature is 296 degree Kelvin. Temperature of gases given is 300 degrees Celsius plus 273. 573 is absolute temperature of hot gases. Then mass of air taken for combustion of fuel is 25 kg per kg of fuel. Then draught loss is equal to 50% of theoretical. That is nothing but actual draught produced in terms of hot gas is equal to 50%, 0.5 of theoretical. So 50% is lost. So what we have to find out is HW. We have to find out draught produced in terms of water column, then velocity, then theoretical Hg, then actual Hg. So here HW is the draught produced in water column. Already we have derived this equation. So where H is the height of chimney and T is ambient air temperature. So we know H, we know TA, this TA is known, this Tg is known, Ma, mass of air is known, per kg of fuel, this is known. Everything in this equation is known. So we can find out what we say draught produced in terms of water column, and that will be in of water. Then to find out, actually what we have to find out is velocity. So to find out velocity 2g hg, so this is one formula. So we want to find out hg. So here he is asking us to find out actual velocity. So to find out actual velocity we must know hg actual. So to find out hg actual we have to multiply it by 0.5 with hg theoretical, head loss, or sorry, draught produced in terms of gas column. So this draught produced in gas column is required here. So actual draught produced in gas column we can obtain from here, and that we can substitute. So draught produced in gas column theoretically is obtained by this formula which already we have derived. So now to start with this, we will be finding this HW, draught produced in water column. HW is equal to 353 H divided by TA in bracket 1 minus TA divided by TG MA plus 1 divided by MA, close this bracket, close this bracket. So now HW is equal to 353 into H value. The height of chimney is 25 meters, so you can say 25 meters. The height of chimney is 25 meters divided by TA, temperature of ambient air in degree Kelvin is 296 degree Kelvin. So 296 divided by 296 into in bracket 1 minus TA, temperature of air is 296. 296 divided by gas temperature in degree Kelvin is 573 degree Kelvin. 573 into mass of air. Mass of air is given as 25 kg per kg of fuel, 25 kg per kg of fuel. So this is 25 plus 1 divided by 25, close this bracket, close this. So you will get, on simplification, this as 13.7 mm of water. But question which is asked is in centimeters of water, so it is 1.37 centimeters of water. So this is HW which is asked in this problem. Draught produced in water column is obtained. So if we see in this problem itself, theoretical draught in centimeters of water, this is theoretical draught. He is not asking actual draught, theoretical draught in water column. Then coming to next, so to find out velocity, we must find out draught produced in gas column. Hg theoretical is equal to H in bracket Ma divided by Ma plus 1 into Tg divided by Ta. This derivation we obtained in previous class, minus 1. This is equal to H, we know 25, into Ma. Ma is also 25, I think. Height of tower is 25, mass of air is also 25. 25 divided by 25 plus 1 into Tg is, temperature of hot gases is 573 degree Kelvin. Air temperature is 296 degree Kelvin, 296 degree Kelvin, minus 1. On simplification, we get this as 21.53 meters. So this is the theoretical draught produced in hot gas column. The actual draught produced in hot gas column is given by 0.5 times the theoretical draught produced. So 0.5 into 21.53. So this works out to be 10.76 meters. So to find out velocity of gases, actual velocity, we can say is equal to square root of 2g hg actual. So square root of 2 into g is 9.81 into 10.76. On simplification, we get velocity of hot gases as 14.53 meters per second. So the results have to be written here. Answer: number 1, the draught in centimeters of water is given as 1.37. HW is equal to 1.37 centimeters. This is first answer. Then second, so second he is asking us to find out the velocity of flue gases passing through chimney. The actual velocity of gases V is equal to 14.53 meters per second. So this is how we simplify the numerical, very simple numerical. So tomorrow we will be solving few more numericals, and we will be completing this unit.